Hi everyone, my name is Jeff Gradus. I'm the Vice President of Tantec USA. Today's webinar is going to be focused on why does my glue, coating, or ink fall off my material. Tantec was founded in 1974. Our core focus and efforts in surface treating are related to three-dimensional object treating. We do this with a combination of corona and atmospheric plasma along with vacuum plasma. Typically with a corona-based process, we have a high voltage electrode that's going to be discharging onto the part with a grounded base down below. The grounded base actually pulls the energy out of the electrode to create that surface energy change that we're looking for. So in order for this to work properly, you need a customized or specialized electrode, a customized fixture for the part to sit in with a grounded base below that's going to go ahead and create the effect that we're looking for. So corona solutions are a little bit more tailored and customized. Then we go over to our atmospheric plasma systems, which are done with our plasma nozzle system. Inside the nozzle, we still create a high voltage arc. However, we're rushing compressed air through the arc, which is then blowing out ions onto the surface. Similar to what Corona is doing, just doing it inside the nozzle and allowing us to work in an inline process or without that grounded base. So we don't need to pull the energy towards it. We do it by pushing the air out and focusing the nozzle directly where it needs to go. The other technology we have here at Tantec is vacuum plasma. This is more of a batch-based process where we're going to go ahead and set parts onto a tray, pump down, and create a plasma field inside the chamber. This plasma field is doing the same that the corona and atmospheric plasma is doing, which is etching or functionalizing that surface to allow your glue, your ink, or your coating to stick better onto the surface. We're going to show a quick animation here that drills down to the molecular level of what plasma and corona surface treatment is actually doing to the surface to give you a better concept as to why it works, how it works, and what to expect from the process.
Plasma is the fourth state of matter. Like gas, it doesn't have a definite shape or volume, but some of its particles are ionized, meaning that they have lost or gained electrons and a certain amount of electrons are free. It also contains some ground and excited state atoms, and, importantly, free radicals, including oxygen. But why do we need plasma surface treatment in the first place? The surface energy of the solid substrate directly affects how well a liquid wets the surface and thus determines the adhesion of inks, glues, paints, and coatings. Wetting can be measured by the contact angle of a bead of liquid on the surface. It may spread out over substrate and the contact angle will approach zero if complete wetting takes place. Conversely, if wetting is low, the resulting contact angle will be significant. Plastics made of polymers, such as polyethylene, have low surface energy because the surface particles are nonpolar, meaning that they are electrically neutral and do not attract other molecules very well. In such case, the particles of the liquid are attracted more strongly to each other than to the surface. If the surface energy is greater, then the liquid will spread and consequently wet the surface better. Plasma treatment is an excellent way to increase the surface energy. The radicals, created by plasma, break the polymer chains of the material and oxygen-containing molecules are attached to its surface. These functional groups are polar, meaning that they attract other particles with much greater force. This results in increased wettability and therefore allows the plastics, metals, and glass to be easily and perfectly printed, painted, and coated, glued, or simply wetted.
There are a few techniques we use here at Tantec and industry-wide for measuring the effect of the change of surface energy on the part after a corona or plasma treatment. One is using contact angle, the other is using dyeing solutions, and in many cases we do a tape test or a functional test. One of the key takeaways here is anytime we do any type of surface treatment, the measurement using contact angle, dyeing, or a tape test really should be followed up with our customers doing their actual process to confirm that the change we made on the part really amplifies and enhances the adhesion that they're looking for. The surface energy testing is great for just understanding what has been done, but it doesn't replace the need to do the actual confirmation and firm testing to ensure it does meet the requirements you're looking for. Later on in the webinar, we'll be taking a few moments to show you how we do some of this testing up close so you can see the effect of a before and after treatment. Some of the key advantages to plasma and corona treatment are helping to remove primers from the environment, eliminating costs. It's a very, very low cost system to run. In many cases, we're just using electricity to operate the system. And then with these, we will use some compressed air. Very, very low operating cost, fast return on investment. Also protecting your operators from being exposed to VOCs, harmful chemicals that are typically used for etching and enhancing adhesion in a very, very caustic manner. So it's really great for the environment, for your employees, and low cost, and customizing the solution to fit your production process without impacting what you're currently doing now. Those are just a few of the key advantages. We'll be touching more on some of the difficult treat materials, how we can work with those, and how plasma and corona can play into that. One of the new developments here at Tantec is a process we've come together with the Fraunhofer Institute. It's called the VacuTech CodeTech system. This is where we're taking vacuum plasma and we're now enhancing that with a coating directly inside the chamber. So we're still doing our typical technology of etching the surface or functionalizing the surface under vacuum, where we create that plasma field while the parts are being treated. But during that process, we also inject a coating into the chamber in the monomer nanometer type filling process, where it's going to go ahead and attach itself to the surface of the parts. This is all done in a single chamber, so there's no need to go from a treating process to a coating process. We're able to do it all in the single chamber itself. We'll be showing a quick video here to explain a little bit more how this coating process comes together, an application that we've had with a customer, and we'll be touching a little bit more on this process throughout the webinar.
The Rohloff Speed Hub is known for high quality products, and in order to remain there and stay there, you have to regularly assess production processes as well as components, try to improve those. In the area of one ball bearing, we had the situation of very confined space, thus no chance of using a radial seal. Ever since, we've been using liquid seals, and those brought the problem of limited adhesion with metal components around it with it. In order to find a solution, we've been contacting Tantec and Fraunhofer IST, whom we worked before on other projects, and we were very happy to have identified a solution there.
Our knowledge is to adapt the right coating to the right material combination. And this we can do very fast and adapt this in the machines. Plasma and corona treatment is often used in the industry to optimize the adhesion. But this was not the case here in this project. So we used the coating process to optimize the adhesion between the two components here at Rohloff.
Thanks to both partners and their experience, it was possible to develop an efficient and economical process for us in a pretty short time.
The process is divided in several steps. In the first step, we make a cleaning of the surface by a plasma. In the second step, we add a so-called precursor. And with this precursor, we add a very few nanometer layer on the surface to improve the adhesion. In summary, we can say that it's very environmental friendly because we use less chemistry, less energy to produce such coating. So the coat process offers a solution of many markets. For example, aviation, mobility, or pharmaceutical or medical products.
The plasma coating solution developed by Fraunhofer IST and Tantec works very well. It goes without saying that we can recommend such a collaboration to others that might be facing similar challenges out there.
We deal with a lot of different polymers and metals here at Tantec in terms of the surface treatment effect. Some of the materials that you're typically going to run into are polypropylenes, polycarbonate, polystyrene, ABS, And then also we work with a lot of metals as well. So these materials are a little bit more challenging to work with because they're designed to resist things sticking to them. Polypropylenes, polyethylenes are typically low surface energy materials where they do benefit from the change in surface energy. Polycarbonate and ABS, they've got a little bit higher surface energy to start with. However, they still do need some sort of surface treatment in order to enhance their properties. As I mentioned, we also work with metals. Metal, we do a lot of metal cleaning and prep. The whole idea behind that is to clean off maybe a contaminant that might be on there, or potentially treat a coating that's on the surface itself to give you more value add to the material overall. So those are some of the low surface energy materials we work with here at Tantec. PTFE is another one that comes to mind. That's a really challenging material. As you might imagine, a fluoropolymer has been designed and developed to have a slippery, flexible surface. So that's why these types of surface treatments are important. It provides that added value to the material. We get the question quite often is, what does low surface energy mean? What does high surface energy mean? Low surface energy means that the material wants to resist anything being put onto that surface. So I like to kind of explain this as you imagine a car that's been sitting in a field for 10 or 15 years. Hasn't been cleaned, hasn't been washed. When you throw a bucket of water on there, it completely sheets out. That's indicating it's got a nice surface energy in terms of the ability for the coating or the glue to wet out onto the surface. Then you take a brand new car out of the showroom that's got a layer of wax on the surface. When you pour that bucket of water on that car, the opposite effect is occurring. The water wants to remain with itself and not spread on the surface. And that's where you would have your low surface energy, meaning that whatever you try to put on the surface and attach to it will not stick overall. You can also look at it from a standpoint of, what are we doing to the surface overall? How are we affecting that? So we're creating these hydroxyl and carboxyl groups onto the surface. You imagine plastic molecules are very, very tightly bonded together. After they're hit with either an atmospheric plasma or a corona-based process, we're trying to break those bonds apart and add these groups to the surface. These groups are attached to the surface, and once you put your coating or your glue onto the surface, you lock in those attachments. If you were to treat a part and then set it on the counter, come back maybe 2 or 3 days later, you won't see the same effect you're going to get immediately thereafter. So the key takeaway there is when you do surface treat a part, yes, surface treatment is temporary until you put your value add onto the part and then you lock it in for the part. So those bonds of those molecules are tightly put together, but when we hit it with plasma or corona, we break them apart, and now we create small peaks and valleys for your glue or your coating to go ahead and attach and wet out onto the surface so that you get that level of adhesion you're looking for, the quality of print, and it gives a long-lasting effect when it's exposed to the environment that you're going to put your part into. We've talked a little bit about the environmental impact of using a corona or plasma treatment. One of the things that we found is people are moving more towards this technology simply because of the difficulty dealing with primers, mechanical pretreatment, and the overall chemicals used typically in the previous processes in order to enhance surfaces. Exposing your operators to primers that have high VOCs, a lot of companies are moving away from that from the environmental aspect as well as safety for their employees. Many states throughout the United States are also outlawing these VOCs. We don't want to expose people to chemicals and fumes, along with the cost and the inventory you have to keep with a primer. Then when we go to like a mechanical treatment, a sandblasting, a shot peening, or some sort of ablation onto the surface with laser, something along those lines, yes, it does change the energy of the part and makes it so that a coating or a glue can stick. However, it is a very messy process. It's very involved in terms of the type of specialty equipment you need to do that. The other thing is a mechanical bond is never as strong as a chemical bond. The chemical bond is working with the plastic. The mechanical bond is where you're actually removing something from the surface. So you run the risk that you're actually going to change the properties of the plastic or metal that you're working with. When it comes to corona or plasma, we're just adding those groups to the top nano layer of the plastic. So we're not actually stripping or removing material. So the bulk properties and the structural integrity of your part are typically not affected with a corona or plasma process that we see more often with a mechanical or an aggressive primer that's meant to really strip into the plastic itself. Corona and plasma can be integrated in various different ways. Plasma is typically done in an inline process on an extrusion, or more commonly done with our robotic setups, where the nozzle is placed on the end of a tool and it comes across and treats a specific defined area where maybe you're putting an inkjet coating, or you're putting a stripe of glue down, or you're putting a tape down for an automotive part, or any other type of part you're trying to enhance the surface with. So robotics and inline is very common with the atmospheric plasma. When it comes to our corona systems, really the sky is the limit on what we can do in terms of integration and automation. We can do tabletop systems where an operator loads and unloads parts individually. It can be put into a dial table or a full automation process where the parts come in and they're treated. They can go on a conveyor. They can be put on different fixtures. So with Corona, it's really going to be how can we implement this into your production process without truly impacting or negatively having you change what you're doing in order to find a solution with Corona or plasma. Those are some of the automation and inline processes that we can do with this. We can certainly look at other variabilities. With our vacuum plasma, that's more of a batch process where an operator is loading and unloading parts directly. However, we have come up with I guess you would say more of a semi-automated process where we have built conveyors into our chamber with auto doors, meaning that you bring your parts onto a conveyor, our doors drop down, parts go onto our conveyor inside, and we move the part into position. The doors come up, treat, and it goes out the other end. What's great about all three of these technologies is you have process control, meaning that if something doesn't go right with the surface treatment process, we provide you the feedback. You will get that information via alarms or some way to let you know that the process wasn't done right. When it comes to primers, you have to rely on the primer being wiped down, and then you have to verify that the primer is there. Same with mechanical ablation. You have to look at that and you have to confirm that it's all happening the way you want it to. When you put a corona or plasma system in, that's going to tie directly into your automation and let you know that everything is going according to plan. So you can feel confident that the changes that we make to these surfaces will show up in the quality of your part. It kind of leads to why people look at surface treatment, the quality aspect of returns, poor product out in the field. So some of the things that we see is, people are putting date codes or lot codes on pharmaceutical bottles or on pipes or wires. It's really important to know what that wire is, especially for somebody going out in the field to maybe, change something in a wiring setup, to be able to recognize and identify what that wire is or the property is of that wire. Having an ink that has been put on the surface that is going to hold for the life of the part is critical, so people know what they're dealing with there. Same for your cell phone, printing on graphics, high-end, high-quality graphics. You don't want that falling or flaking off throughout the field. So it's really, surface treatment is really more about enhancing the product so you get a good quality product in the field that can last and give your brand the integrity it needs to show well when it's exposed to environmental conditions outside of the perfect environment of a lab like this. So that's really why people are focusing on changing to the surface energy using corona or plasma. They want to enhance the quality of their products, provide less of an environmental impact, and a good, safe process for their operators. That's why we're focusing on this webinar to explain a little bit more about how people are moving to that and why the challenges are presented and the value that adding this type of process to your glue or to your products that your glue, coating, or ink can maintain on the surface. A lot of times we get the question is, how do we get started with understanding if corona or plasma is the right solution for what you're trying to accomplish? So one of the first things that we're going to do when we have that initial conversation is just try to understand a little bit more about the part, where you want to treat it, how your production process is going, and have that conversation with you just to understand, is plasma maybe the right solution, or is corona the right solution? Or it's very possible that both could be a solution, just depending on what fits best for your production process. So a lot of key things we like to understand is, Are we treating one side, both sides? Are we treating a specific area or a path around the part? Product thickness. But one of the most important things that we always want to know is what is the material we're treating. There are some materials that may not be as receptive to plasma, and Corona might be the right solution. PTFEs are more likely to be enhanced by Corona versus plasma. So it's just one of those things where we like to gather as much information as we can so that we can best provide you some input. After that conversation takes place, the next best thing we can do is working together to get your samples in-house so that we can come into our lab and actually do a functional test. We can actually apply the plasma to the process or the Corona electrode and create that change in the energy. But then we measure the before and after effects and provide you this test report so that you can actually see that we are impacting the part. And again, if you're using both Corona or plasma, you can see how both are creating that change, and one may create the change a little bit better than the other, and that kind of helps direct you or provide you with the direction you want to go in order to select the solution that makes the most sense. Kind of brings me to a couple of applications we've done recently. One is related to an automotive trim part for a company, an integration company called Hill Machinery. They took our plasma systems and built it into an automated process with robotics in order to treat an automotive part to apply a tape to the surface. Many people be surprised to know that a lot of cars are held together with tape. They're not held together with fasteners and screws and nuts and bolts. A lot of the plastic is just double-sided taped and put into place, and that's where it's really critical that a plasma treatment is done, because you don't want parts falling off of a car in the inside, especially on some of the luxury brands that are out there. If you look at a car that maybe you paid $50,000, $70,000 for, and you go to grab the door handle and it falls off, you're probably not going to be very happy about that. So the plasma treatment is going to enhance that tape's ability to bond to the surface and last the life of the car. The other application was more of a medical device application with a company called Sonotec. They do a lot of ultrasonic spraying systems, and they also do automation where they're doing full turnkey solutions where parts are coming in, they're being treated, and then they're being sprayed after the fact. So they're taking these parts onto a pallet, pulling them through, and creating a cell, if you will, with our Corona system in there. So when the parts are in place, they're treated, and then they can go on to their next value add, which is adding that spray coating onto the surface so that the product performs in the medical industry's specifications for what they're looking for, be it making sure that the media wets out properly or providing a long-lasting coating on the surface that they're looking for. So that's really how we get started and how we go ahead and begin the process of working with your parts, doing the sample testing, and touching on what technology will make the most sense for you. Touching on why and how we go about developing the process and figuring out what technology makes the most sense for you. When you send those samples into Tantec, we do that testing free of charge. So you send your samples in, we provide a test report for you. We do all that free of charge with the hope and the opportunity to explain to you a little bit more about what our technology can do, what enhancements and benefits plasma and Corona can do to your product. Kind of recap some of the benefits of Corona and plasma surface treating overall. One of the biggest things, as we've touched on quite a bit, is to remove the chemical primer process from your production facility. Providing the very, very focused and intense treatment onto the areas that you want it to occur on. The feedback that these systems provide in order to let you know that the process is going well. The ease of integration and automation into the process are some of the benefits to the Corona and plasma. But the biggest takeaway and the best benefit overall is providing a quality product for your customers. So once you create this change on the surface, you put your value add on there. Now you're putting a product in the field that you can feel confident will last the life cycle of the part itself, and your customers will be very, very impressed with the quality of your product, eliminating those returns for something as simple as, why isn't something sticking to my product? Why is my coating falling off? That's really the key benefit to plasma and Corona, is just enhancing your quality of your product so your customers are very happy. I'd like to now demonstrate our SpinTech 30 so you can see kind of the entire process of how we go ahead and do a surface treatment test here in our lab. It's right over my shoulder here, so we're going to go ahead and get that set up for you. So we're going to get set up here now with the SpinTech 30 demonstration. This is our laboratory machine, which allows us to go ahead and simulate your production process so that we can test at your line speed and verify the treatment is meeting real-world applications. So I'm going to take our plastic piece here. We're going to set it on our slide deck tray. This is then going to move across underneath the Tantec 30 rotating system to perform the plasma process so that we can change the surface energy of the part. We have certain settings on here with line speed, allowing us to activate the plasma to and from the treatment, so we can select how many times or how many passes that the part sees during the plasma process. Once we get up and running here, the deck will move underneath the plasma. The plasma will begin spinning and rotating, pushing out the plasma discharge onto the surface of the part. And the process will begin moving underneath, and the plasma will automatically start when the part is in place. On the way back, if we decided to do a second process, the plasma would come on an additional time to simulate if you had two nozzles running. We'll take this part over and do a quick dyne test. One of the things we talked about earlier in the webinar is how do we go about measuring the surface energy of a part after it's been treated. So now that we have this part treated, we're going to go ahead and do a dyne test on the part itself. I brought over 2 bottles of dyne solution, one being a 40, one being a 60. Typically, the general rule of thumb that we've kind of come across in the industry is when you have a low surface energy of 40 or lower, that's when you begin to see adhesion issues with your glue or your coating, your ink not sticking to the surface. Using plasma or corona, in this case we use the Tantec 30, which is an atmospheric plasma. Our expectation is we're going to raise the surface energy to in the upper 50s, 60s, maybe even all the way up to 72. The higher the number, the more likely you are to see enhanced adhesion of your glue or your coating to the surface itself. So the first test we're going to do is with a lower number, which is a 40. This is going to be tested on an area that has not been treated. The expectation here is because it's an untreated plastic, it should have a low surface energy. This test ink should bubble up and not spread out onto the surface. The rule is if it sits for 2 seconds flat, it's that dyne or higher. If it bubbles up instantly, you're below that dyne. So we'll go ahead and do a quick wipe on the surface itself and look to see how it reacts on the plastic. So we wipe it across here. As you can see, we're not leaving any trail or wet out of the surface. The liquid is more attracted to itself than the plastic. And that's what we would say with this particular material, the untreated area is below 40 dyne. That would tell us we need to go ahead and enhance it with plasma or corona to get that dyne level up. Now we go ahead and take a high number like a 60 and we go ahead and wipe over the area where we treated this material as it went by the Tantec 30. And what we expect to see here is the liquid to actually wet out onto the surface and lay and spread out across the treated area, which we're seeing here. So what this tells me is we're at 60 dyne or higher. Dyne is a little bit more of a subjective way of doing it, but it's a quick, easy way to determine what the surface energy of your part is. If you want something more calibrated and more scientific and less user dependent, we would say go to a contact angle system. That's going to drop a pre-calibrated dose of water onto the surface, and it's going to measure the angle for you, and it can give you other details like contact angle. You can use other liquids to get a disperse angle, as well as the polar properties of the part itself. The big takeaway, though, is no matter what information you get from the dyne or the contact angle, nothing beats taking your product and applying your process to it to confirm that these numbers equate to the better adhesion you're looking for. Thank you for joining our webinar. Hopefully we were able to provide some insights with our technology of why your glue, your coating, your ink won't stick to the surface. If you'd like to learn a little bit more about the technology or get into more technical aspects of the surface treatment process that we offer here at Tantec, please reach out to one of your local representatives. Thanks again for joining us.